PPS subject, right? For sorting, for addition of two numbers, multiplication of two numbers, then for patterns, right? Then for function, right? So already you know how to design the algorithm, right? બધાને ખબર છે ને algorithm શું છે?
Yes, ma'am.
Now who will tell me what is algorithm? Okay, Jay Tandil. Tell me what is algorithm? What do you mean by algorithm?
Yes, ma'am. It is a blueprint to write a program.
It is a blueprint to write a program. Okay. Then Prachi, what do you mean by algorithm? Jay said that it is a blueprint to write a program. Right, Prachi? Now what do you mean by algorithm? Prachi Patel. Prachi, are you there? Okay, Darshan.
Yes, ma'am.
Yes, Darshan, what do you mean by algorithm?
It is a set of procedures that describes a program.
This is a set of process that
Describes a program or a process.
this or a process. Okay. So already you know what is algorithm, right? Algorithm is a collection of unambiguous instruction, or it is a collection of instructions occurring in some specific sequence, and such an algorithm should produce output for given set of inputs, right? કોઈ પણ problem છે એને solve કરવા માટે you write down some steps, right? Or you write down some procedure that is known as algorithm, right? So in this subject we learn to design different algorithm to solve different problems, right? And then analyze that algorithm. Now what is analysis of algorithm, right? Analysis of algorithm means we check the space and time complexity of that particular algorithm, right? Suppose there is one problem, that addition of two numbers, right? You write down one algorithm to solve or to find the addition of two numbers, રાઈટ. હવે એ અલ્ગોરિધમનું આપણે એનાલિસિસ કરવાનું છે. એનો મતલબ શું છે? આપણે ફાઇન્ડ કરવાનું છે કે હાઉ કે એ જે અલ્ગોરિધમ છે that is efficient or not, right? And how to check the efficiency of any algorithm? So to check the efficiency of any algorithm we have to find the space complexity and time complexity, right? જેટલી તમારી time complexity ઓછી હશે, your algorithm is more efficient because it gives you output in lesser time, right? So in analysis part we find the complexity of the algorithm, right? And in designing part, using the different methods, right, we solve the problem, right, and write the algorithm for that problem, right? So this is about the subject, right? Now okay, so this is the syllabus of the subject, right? So okay, now your syllabus is designed in this way that covers the analysis part, right? In second chapter you learn the different analysis methods, how to analyze any algorithm, right? Then you learn different sorting algorithms which you already know, right? Different sorting method, bubble sort, selection sort, insertion sort, right? અને દરેક sortingની you find the complexity, right? Then different methods to design the algorithm for different problems, right? So first is divide and conquer, then dynamic programming, then greedy programming, then different algorithm for graphs, right? Then backtracking and branch bound, then string matching and NP completeness, right? So this is the core subject of computer engineering, right? Whenever you apply for masters, then in any entrance exam there are some questions, right, uh, from this subject, right? So it is very important for a competitive exam, right? And this subject will also be there in your master's curriculum, right? So it is very important to uh, know the different methods, how to design the algorithm and how to analyze the algorithm, right? So as per syllabus point of view, or as per uh, competitive exam point of view, uh, for your further study, this subject is very important, right? So first we will start with the first chapter, that is basics of algorithm and mathematics, right? In this chapter, we learn what is algorithm, different properties and characteristic of algorithm, right? Then different mathematics, sets, function, relation, vectors, how they used in algorithms, right? So let us start with the first chapter. Kushal sir will start the second chapter, that is analysis of algorithm, right? Uh, if you properly understand the second chapter, right, then it will be very easy for you throughout the semester, right? So please pay attention in this second chapter, that is analysis of algorithm, right? So let us start with the first chapter, that is basics of algorithms and mathematics. Okay, so introduction to algorithm, right? Already we discussed what is algorithm, right? So whenever in exam definition of algorithm will be asked, then you have to write down like this. An algorithm is a step-by-step procedure to solve the different kinds of problem, right? Or another definition of algorithm is the algorithm is defined as a collection of unambiguous instructions occurring in some specific sequence, and such an algorithm should produce output for given set of input in finite amount of time, right? Now let us understand the algorithm with simple day-to-day example, right? Now suppose we want to make a chocolate cake, right? Suppose we want to make a chocolate cake. Then first step is input, right? Means ingredients. You require ingredients if you want to make a chocolate cake, right? So these are the ingredients or input for chocolate cake, right? Then next step is process, right? First you require the inputs, so collect all the inputs, right? Then write down the process or procedure or recipe, right? તમારી પાસે ingredients બધા છે, પછી તમને શું જોઈશે? Recipe, right? So how to make the chocolate cake? So process means recipe in this case, and it will give you the final product, that is your cake, right? So અહીંયા આપણે શું કર્યું? We gather some input, right? Then some process on that particular inputs, right? And after processing that inputs, we get the output, right? So this process, right, is known as algorithm, right? Step-by-step solution for any problem is known as algorithm, right? So, an unambiguous sequence of computational steps, right, that transform the input into the output. Right now, what is unambiguous? What is unambiguous? Anybody knows what is unambiguous? કોઈને ખબર છે unambiguous એટલે શું? Right? Unambiguous means only one solution. Right? एक specific sequence. Right? Ambiguous means more than one solution. Right? So unambiguous means only one solution. So one specific sequence of computational steps that transfer the input into the output. It is known as algorithm. Right? A process or a set of rules to be followed to achieve desired output, especially by the computer. Right? So now our algorithm is ready to make a cake. Right? So એ જ આપણી પાસે steps છે એને હવે આપણે એને કમ્પ્યુટરાઇઝ કરવાનું છે. રાઈટ? હવે શું છે? પ્રોબ્લેમ શું છે? એડિશન ઓફ ટુ નંબર્સ. રાઈટ? સો ફોર એડિશન ઓફ ટુ નંબર્સ વી રિક્વાયર્ડ ઇનપુટ. સો ઇનપુટમાં શું હશે? બે નંબર. પછી એ બે નંબર પર તમે પ્રોસેસ કરશો. સો દેટ ઇઝ યોર અલ્ગોરિધમ. રાઈટ? તમે સ્ટેપ્સ લખશો. રાઈટ? અને ઇટ વિલ ગીવ યુ output. Right? So algorithm is an input for program. Right? So this algorithm will be converted by the computer into set of rules, and this set of rules is known as program. Right? And this will give you desired output. Right? So an algorithm is any well-defined computational procedure that takes some value or a set of values as input and produces some value or a set of values as a output. Now let us see the different characteristics of an algorithm. Right? So first characteristic of algorithm is finiteness. Right? So an algorithm must always terminate after a finite number of steps. Right? તમે કોઈ પણ algorithm design કરો, so you have to design your algorithm in such a way, so after the finite number of steps, your algorithm must be terminate. Right? Next characteristic is definiteness. Each step of algorithm must be precisely defined. Right? So each and every step of your algorithm must be precisely defined. So whenever you design any algorithm, right, each and every steps of that algorithm must be precisely defined. So that is definiteness. Next is input. An algorithm has zero or more inputs. Right? તમારી પાસે inputs હશે, then only you can write down the solution steps. Right? So an algorithm has zero or more inputs. Output, an algorithm must have at least one desirable output. Right? Then effectiveness, all the operations to be performed in the algorithm must be sufficiently basic so that they can in principle be done exactly an infinite length of time. Right? So this is known as effectiveness. Right? Now, in spite of this characteristic, right, let us understand the different properties of algorithm. Right? So simple writing the sequence of instructions as an algorithm is not sufficient to accomplish the certain task, right? So we have to follow the certain properties, right, which is associated with the algorithm. So properties of algorithms are non-ambiguity, right? Now what is non-ambiguity? Any definition માં જ આવે છે, right? So each step in an algorithm should be non-ambiguous. It means each step in algorithm should be clear and precise, right? So definiteness is also known as non-ambiguity, right? Then range of input. So range of input should be specified, right? Next is multiplicity, right? Now suppose your problem is addition of two numbers, right? So for addition of two numbers, the same algorithm can be represented in several different ways, right? તમારો અને મારો algorithm અલગ થઈ શકે, right? So that means we can write in simple English sequence of instruction, or we can write in form of pseudo codes, right? Similarly, for solving the same problem, we can write several different algorithms, right? Next is speed. So the algorithm are written using some specific ideas, but such algorithm should be efficient and should produce the output with fast speed. It means time complexity of the algorithm must be low, right? Next is finiteness, right? That we already discussed, right? The algorithm should be finite. That means after performing required operation, it should be terminated, right? So these are the different properties and characteristics of the algorithm, right? Now, next is whenever you start writing the algorithm, right? So it may be possible that you can face the various issues, right? So there are various issues while you write the algorithm. So first issue is how to devise the algorithm, right? Then how to validate the algorithm, how to analyze the algorithm, how to test a program, right? So these are the different issues when you start writing the algorithm, right? So next is let us discuss the types of algorithm. So these are the different types of algorithms, right? First is simple recursive algorithm, right? Now what do you mean by recursive? Already you learned the recursion in your PPS. Anybody knows what is recursion? Calling itself, right? Some function or some program calling itself, right? Then it is known as recursion, right? So simple one type of algorithm is simple recursive algorithms, right? Second is backtracking algorithms, right? Now what is backtracking? Backtracking means after uh, executing the instructions of any algorithm one, right? And at the end or at some point of time, if you cannot get the desired output, right, at that time you have to again move to previous steps, right? Again backtrack to previous steps. So that is known as backtracking, right? So another type of algorithm is backtracking algorithm. Third type of algorithm is divide and conquer algorithms, right? In divide and conquer algorithm, we divide our data set into two or more parts, right? Then apply the algorithm on each individual set. Then after applying the algorithm, again we conquer or gather the outputs of each and every part, right? And get the desired output. So that is divide and conquer algorithms, right? Next is dynamic programming algorithm. And there are different algorithms which are under the categories of dynamic programming, right? So that we will learn in next to next chapter, right? Next is greedy algorithms, right? Then branch and bound algorithms, right? And brute force algorithm. Brute force means, what do you mean by brute force? Trial and error, right? So that is brute force algorithm, right? And randomized algorithm, right? So these are the different types of algorithm that we will learn in this subject, right? Okay. Now already all of you know how to write the algorithm, right? PPS માં તમે શીખી જ ગયા છો કે algorithm કેવી રીતે લખવાનો. So no need to repeat here that again, right? જેમ જેમ આગળના ચેપ્ટરમાં આપણે algorithm આવશે તેમ તેમ હું તમને કહી દઈશ કે algorithm આ રીતે લખવાનો, algorithm આ રીતે લખવાનો, right? Now next part of this subject is analysis of algorithm, right? So whenever we want to analyze any algorithm, right, we should consider some factors, right? So which factors we have to consider when we analyze the algorithm, right? So first factor that we should consider is time efficiency of an algorithm, right? Then second is space efficiency of an algorithm, right? Then just wait 1 second. City આપણને કઈ રીતે ખબર પડે કે એનાથી આપણે શું ખબર પડે કે algorithm is slow or fast, right? Second is space complexity. So space complexity of an algorithm means the amount of space, it means the amount of memory taken by that particular algorithm, right? And after computing the space complexity, we can analyze whether the algorithm requires more space or less space, required more memory area or less memory area, right? Third factor that we have to consider at the time of analysis, it is simplicity, right? And simplicity of an algorithm means generating sequence of instruction which are easy to understand, right? આપણે એવી રીતે algorithm ડિઝાઇન કરવાનો કે એ કોઈને પણ જોઈને એને સમજ પડી જાય. So your algorithm must be simple, right? That is next one is generality. Generality means design an algorithm in more general way rather than designing it for particular set of inputs, right? કોઈ particular input માટે algorithm design કરો એના કરતા એને algorithm design કેવી રીતે કરવાની, general કોઈ પણ input પર applicable થઈ શકે એ રીતે. And last one is range of inputs, right? So range of inputs means the design of an algorithm should be such that it should handle the range of input which is the most natural to corresponding problems, right? So in short, analysis of algorithm means checking the characteristics such as time complexity, space complexity, simplicity, generality, and range of input, right? And if these factors are not satisfactory, then you have to again redesign the algorithm. If space complexity, time complexity, simplicity, generality are not satisfied, right, then you have to redesign the algorithm. So this is about the analysis of algorithm, right? Now let us discuss the mathematics for algorithmic set, right? To design any algorithm we require some mathematics set, right? So which mathematics sets are used for designing the algorithm or analysis the algorithm, right? So okay, okay. So a set is defined as collection of distinct objects, right? And these objects are called elements of the set, right? These objects are called elements of the set or members of the sets, right? And each and every elements in the set are enclosed within these curly brackets, right? And every element is separated by the commas. દેખાય છે બધાને?
Yes, ma'am.
Right? So, okay. So, if small a is an element of set capital A, then we can say that A is a set of capital A, right? And typically, all the sets are denoted in capital letters. જ્યારે પણ આપણે capital letters માં કંઈ પણ લખશું, right? અને જ્યારે પણ આગળ કશે પણ example માં capital letters હશે, એનો મતલબ શું છે? એ set છે. Right? So here capital A is a set, capital B is a set, right? So representation of set, right, with the curly brackets, and each and every objects of set are separated by the commas, right? So this is known as roster notation, right? Now this notation is known as set builder notation, right? In this set, C is equals to, in curly bracket, x is an odd integer greater than 1, right? So આ સેટના objects કયા કયા થશે? કે જેની value greater than 1, odd integers, જેટલા પણ odd numbers છે જે greater than 1 છે, are all part of C, right? And set D is equals to x is a element of C and x less or equals to 11, right? X is an element of C and x is less or equals to 11. So x is less or equals to 11. So D na objects કયા કયા થશે? જે 11 થી નાના છે. અને C ના object છે. So C માં કયા કયા numbers છે? Odd number. So all the odd number less than or equals to 11 are object of set D. Right? So we can represent set like this or like this. Right? So these are the two examples to represent the set. Right? Now, next is different types of set. Right? First is finite and infinite set. Right? Now, a set is finite if it contains finite number of elements. Otherwise, it is infinite set. If any set contains a finite number of element or object, then it is finite set. Otherwise, it is infinite set. Right? Now, here, this first example is for finite set because A contains finite number of elements, right? And this example is for infinite set because B contains infinite number of elements. Getting? Set A is a finite set and set B is an infinite set. Now, next term which is used in set theory is subset. Right? So, for two sets A and C, we say that C is a subset of A written as like this. C is a subset of A. Right? આવી રીતે જ આપણે લખવું હોય આ સાઇન નો મીનિંગ શું થાય સબસેટ રાઈટ સો આ સેન્ટેન્સ નો મીનિંગ શું થાય C is the subset of A if each member of C is also member of set A. Right? C ના જેટલા પણ મેમ્બર છે એ બધા A ના પણ મેમ્બર હોય then we can say that C is a subset of A. Right? So this is about subset. Next is proper subset. A proper subset of A is a subset of A that is not equal to A. Right? Now consider this example. If A is equals to 135 and B is equals to 15, then set B is a proper subset of A. Now consider this second example. A is equals to 135 and C is equals to 135. Then set C is a subset of A, but it is not a proper subset of A since C is equals to A. It means proper subset ક્યારે થવાય જ્યારે C ના જેટલા પણ objects છે right or elements છે એ બધા જ A માં હોય then it is not proper subset, it is only subset. Right? બંને સેમ નહીં હોય પણ બંનેના એલિમેન્ટ સેમ હોય then it is subset. Right? પણ બંનેમાં ડિફરન્સ હોય પણ એક બીજાનું સબસેટ હોય then it is known as proper subset. Right? So this will represent like this. B is a subset of A, and if A is equals to, B is a proper subset of A. So this is a sign of proper subset, right? And if A is equals to C, then C is equals to subset of A. Right? Next is power set. The power set is a set of all the subsets of its element. It means consider the set A, right? Now the power set of A written as P of A is the set of all subsets of A. Right? So for example, A is equals to 0, 1, then the power set of A is equals to null, then 0, 1 and 0. A na જેટલા પણ subset હોય, right? It will become the power set of that particular set. Right? Now next is cardinality of set. Now cardinality of a set denotes the number of elements in a set. The cardinality of set S is denoted by NS or like this. Right? Now, for example, if S is a set of English alphabet, then cardinality of S is equals to 26 because there are total 26 alphabets in English. Right? Now, cardinality of infinite set X is denoted by cardinality of X is equals to infinite. And cardinality of empty set is denoted as null. Right? And null is a unique set whose cardinality is 0. Okay. Next term in set theory is complement. Right? The complement of a set A is the set A dash that contains every element of the universal set U but not in A. right? And it is denoted as A dash, right? So A dash is equals to X such that X is a element of U and X is not an element of A. Now consider this example. U is equals to U is for universal set, right? So U is equals to 13579, right? And A is equals to 135. So A dash, that means complement of A is equals to that all the elements in U but not in A sorry, but not in A. So A માં કયા કયા એલિમેન્ટ છે 1 5, right? So U ના 1 5 સિવાયના જેટલા પણ એલિમેન્ટ છે that will become the complement of this set A, right? So A dash is equals to 379. Getting? Right? Consider this is the universal single box, right? Now this circle represents, તો A dash માં કયા હશે સિવાય બધા, right? So A સિવાયનું જેટલું પણ છે that will be complement of A. Complement of A માં કયા કયા element હશે that is part of U but not the part of set A, right? Next is union, right? So the union of two different sets A and B is the set of all distinct element of set A and B, right? So union of two sets will be represented like this: A union B is equals to X such that X is a set of us, X is an element of A or X is an element of B. Just give me 1 minute. Union. Okay. So the union of two different set A union B is equals to X such that X is a set of A or X is a set of B, right? બંને બેમાંથી એકનો પણ જો member હોય then it will be there in A union B, right? So consider A is equals to 13579 and B is equals to 12345, right? So A union B માં શું આવશે? All the elements of A or elements of B, right? So first 1, right? Then 3, then 5, 7 and 9, right? Now or 1, 2, 3, 4, 5, right? So all the elements in A or B is a part of A union B, right? Now next is this will represent like this, right? This represent the set of A, right? And this will set of B, elements of set of B, right? So A union B, right? All the elements of A or all the elements of B, right? Next is intersection. That is the intersection of two sets A and B is the set that contains all elements of A that also belongs to B, but no other elements. Right? So A intersection B will be represented like this: X such that X is a element of A and X is of B. Right? So consider this example: A is equals to 23579 and B is equals to 123. Right? So intersection માં કેટલા elements આવશે? જે A માં પણ છે અને B માં પણ છે. Right? The elements are in A and B also. બંનેમાં હોય એ જ. Right? So એવા કયા elements છે જે બંનેમાં છે? 3 and 5. Right? So A intersection B is equals to 1, 3 and 5. That will be represented like this. Set A, set B, right? અને A intersection B. So બંનેમાં જે common હશે, that will be answer output of A intersection B. Right? Next is set difference. Right? The set difference A minus B of two sets A and B is the set of elements that are in A but not in B. Right? So that will represent like this: A difference B is equals to X such that X is a element of A and X is not an element of B. Right? So consider the example: A is equals to 13579 and B is equals to 12345. Right? So A difference B માં કયા કયા આવશે? જે A માં છે પણ B માં નથી. Right? So એવા કયા element છે જે A માં છે પણ B માં નથી? So that is 7n, because 135 is there in B. Right? But 79 is not there in B. So A difference B no answer આવશે 7 and 9. Right? A માં છે પણ B માં નથી. So that will difference of two set. Right? So it will be this. Set A at B. Right? And A difference B means જે A નથી. Right? Next is symmetric difference. So the symmetric difference A difference B of two sets A and B is the element that are in A but not in B, and the elements that are in B but not in A. Right? So that will represent like this: A minus B union B minus A. Right? So consider A is equals to 13579 and B is equals to 12345. Right? So kaya kaya element આવશે? A difference B. Right? So A difference B કયું થશે? 79. Right? So A difference B નો answer છે 79 અને B difference A નો answer શું આવશે? જે B માં છે પણ A માં નથી. So B માં છે પણ A માં નથી, એ કયા કયા છે? 2 and 4. Right? અને બંનેનું union. So 7924. So this will be known as symmetric difference. Right? Set A and B. First is A minus B. Right? So this part, and B minus A means this part, and બંનેનું union. So that will become the symmetric difference between two sets. Right? Now next is sequence. A sequence of object is a list of objects in some order. Example: sequence 7, 21, 57 would be written as 7, 27, 57. In a set, the order does not matter, but in sequence, it does. Right? Repetition is not permitted in a set, but repetition is permitted in a sequence, so that 7, 7, 21, 57 is a different from 7, 21, 57. Right? Now, tuples. Right? So finite sequences are called as tuples. For example, 7, 21 is 2 tuples, 7, 21, 57 is 3 tuples, 7, 21, up to k is k tuple. Right? જેટલા પણ element હોય, that number will become the tuples number. Right? Next is Cartesian product. Right? A Cartesian product A cross B of two sets A and B is the set of all order pairs A comma B, where A is element of A and B is element of B. Right? So A cross B is equals to A comma B, such that A is a element of A and B is element of B. Consider one example. A is equals to 1, 2, 3 and B is equals to xy. So A product B is equals to 1 comma x, 1 comma y, 2 comma x, 2 comma y, 3 comma x, 3 comma y. Right? So this is known as Cartesian product of two sets. Now next is relation. Right? So a relationship is a major aspect between two objects. Even this is true in our real life. Right? So definition of relation in terms of set theory is the relation R is collection for the set S which represent the pair of elements. Right? So let two sets A and B. Any subset R of their Cartesian product A comma A cross B is a relation. Right? A relation defines the relationship between values of sets. Right? It is defined between the x values and y values of the ordered pairs. Right? The set of all x values is called the domain and the set of all y values is called the range. Right? Now properties of relation. First property, a relation R on set is reflexive. Right? Let A be set and let R be a binary relation on A. Relation R is reflexive if X is a element of A, such X comma X is a part of relation R. Right? For example, A is equals to 1 comma 2. So relation R1 is equals to A comma B, A less or equals to B. Right? We have one set 1 comma 2. And a relation શું છે બે વચ્ચે? A comma B such that A less or equals to B. Right? So R1 is equals to 1 comma 1 because 1 is equals to 1, 1 comma 2 because 1 is less than 2 and 2 comma 2 because 2 is equals to 2. Right? So this is the relation for this given set A. Right? And 1 comma 1 and 2 comma 2 are reflexive relation. Right? Now B is equals to 1, 2, 3. So this is the relation set for that set B. Right? And this is non-reflexive since 3, 3 is not part of the relation R2. Right? Next property of relation is symmetric. Right? A relation R on a set A is called symmetric if y comma x is subset of R whenever x comma y is subset of R for some x comma y is subset of A. Right? So consider the example A is equals to 1, 2, 3 and relation R1 is equals to 1 comma 2, 1 comma 3, 2 comma 1, 2 comma 3, 3 comma 1 and 3 comma 2. Right? So here 1 comma 2, 2 comma 1, then 1 comma 3, 3 comma 1, 2 comma 3, 3 comma 2. So it is symmetric relation. Right? Now this is asymmetric relation. Right? Because અહીંયા 1 comma 2 છે પણ 2 comma 1 નથી. Right? 1 comma 3 છે પણ 3 comma 1 નથી. So this is asymmetric relation. Right? Okay, so it's 10:50 already. So we are stop here. Right? We will see the another properties of relation in next lecture, right?